Alright, so I feel like extra motivated right now, and I just did the section 4.2 video, 6 o'clock on a Saturday night. That's really disturbing to be here, but this room is I can only record these videos in a classroom, and I need to be in it when there's nobody around, so this is a great time to do this. So section 4.3 hopefully again is a kindish section, and let me see what I can do here. First thing I want to do for this problem, problem 2, is just describe the transformation that occurs compared to f of x equals x squared. And very specifically, the minus 2 in the parentheses is going to shift the graph to the right 2. So I'm just going to be lazy. And I'm going to say compared to x squared, it's going to be right 2. And then plus 6 is going to move me up 6. So the vertex, instead of being at 0, 0, it's going to be at 2, 6 for what it's worth. But I'll find that very quickly when I follow the rest of the steps. Question part B says make a table of values. When I make a graph of a parabola, I usually do 5 numbers in my x column, which means I'll get 5 points. I could label the y column as y, or I could call it g of x. What I generally do to sketch my graph is take the number inside the parentheses and change its sign. Take that number and put it in the middle of the x column. So the number in the parentheses is negative 2. I'm going to put a positive 2 in the middle of my x column. And then I'm going to find that positive 2 on the x-axis. And I'm going to fill in the x column by finding numbers on the x-axis that are to the right and left of 2. To the right of 2, I see 3 and 4. On the x-axis, to the left of 2, I see 1 and 0. So my table for every graph that I'm going to do is going to be similar. It's going to have 5 numbers in the x column. I'm going to take the sign of the number inside the parentheses, change that sign, plot that, find that on the x-axis, and take 2 numbers to the right, 2 numbers to the left. There's my values. And now I'm going to ultra cheat. I'm going to use my calculator to get the y's, because I don't want to run all these y's by hand. So I'm going to get back into my calculator. I'm going to clear out any function that was in there. This plot 1 that's on, I need to shut it off. So I'm going to go up to the plot and hit enter. Well, I'm at second stat plot, and then I just shut it off. I don't know how I magically did that by just hitting second and stat plot, but you need to get the plot off. So if the plot is on, if you get into the plot, you could arrow over and shut it off. So when I hit my y equals, if any of the plots are showed, that's not good. Second thing is, if I'm going to make the y's from my table here needs to increment by 1. If I hit my second and table set button, as long as this delta table says 1, you're going to be okay. When you hit second in window, if this delta table doesn't say 1, then that might mess you up. Similarly, if the autos aren't highlighted here, if I'm using my calculator to get the y coordinates, if it's on ask, my table won't work. So when you hit second and table setup, as long as the delta table or change table is 1 and the autos are highlighted, that's fine. My table starting at 21, let me start my table at 0. And that wouldn't matter. It'd just make it so I don't have to arrow as far. So now I have my table set up nicely. I'm at my y equals button. I'm doing x minus 3 squared plus 6. This is a graph. Well, my window's no good. Let me go to zoom standard, because my window was set up from the last section. When I hit zoom standard, it'll set my window nicer. That's the graph I'm attempting to produce. To fill in my y's, I hit my second in my table, and I just try to find each y. So for x equal to 4, the y is going to be 7. For x equal to 3, the y is going to be 6. For x equal 2, the y is going to be y equals x. I was supposed to do x minus 2 squared. I wrote x minus 3 squared. That was making bad things happen. So let me regraph it and retable it Next to the 4 was supposed to be a 10. Next to the 3 is supposed to be a 7. Next to the 2 is supposed to be a 6. That's going to be my vertex. Next to the 1, there's going to be a 7. Next to the 0, there's going to be a 10. It's always on my tables that the top and the bottom y's are equal. And now I'm going to plot these, and I'm not going to be that terribly accurate. I just don't need that accurate of a graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm plotting the points 4, 10, 0, 10. So here's 0, 10, 4, 10. Probably be nice if you label the points, but it's hardly a deal if you don't. 3, 7, and 1, 7. And then the vertex of 2, 6. And then this looks more or less what my calculator gave me. I'm going to extend the graph and put some arrows at the end. So that's making a table and sketch a graph done. To do the domain and the range, because this is a polynomial, the domain is going to be negative to positive infinity. I'm not going to do any work for the domains because the graph is going to go all the way to the far left of the x-axis if I go out far enough to the left with the graph and far enough to the right. So the domain for all of these is going to be negative to positive infinity. Because they're polynomials, I can get the domain without the graph. The range, though, is a little bit harder. For the range, I need, for this one, the y-coordinate of the bottom point, which is going to be 6. And this graph goes up forever, and the top of the y-axis is at infinity. The y-coordinate of the top of the graph is going to be infinity. So I'm kind of speeding through the domain and range because we've done that a couple times. Square bracket on the 6, round bracket on the infinity. Where the function is increasing and decreasing, the vertex is where it changes directions. This portion of the graph is where it's increasing. From the vertex to the right, the graph is increasing, and to the left of the vertex, the graph is decreasing. And I have to describe those in intervals. This interval is the interval from 2 to infinity, so it's increasing to the right of 2. And again, I'm kind of speeding through this a little bit because it's theoretically review. And then to the left of 2, it's decreasing. And this is from negative. This is from the far left edge of the x-axis to that 2, so it's decreasing. From negative infinity to 2. Usually only round brackets on the increasing and decreasing because at the vertex it's not decreasing or increasing. This one doesn't have a maximum, but it does have a minimum. So for part E, the graph doesn't have a local maximum. It does have a local minimum. The vertex is a minimum here, so it has a local minimum at x equal 2, and the minimum y value is y equal to 6. So I've answered everything that needed to be answered, described the transformation, right, 2 up 6, made a table of values, sketched the graph. All domains of parabolas are negative to positive infinity. The range went from the bottom y 6 to the top y's infinities. Because the vertex was a minimum point, it doesn't have a maximum. And the x-coordinate, we say there's a local minimum at the x-coordinate of the vertex, and the local minimum value is the y-coordinate of the vertex. That's everything that's asked for problem 2. All the first problems are going to be similar. So the left, right, up, and down for number 4, this plus 1 in the parentheses is going to move it left 1. So I'm going to be very efficient here and say it's moving left 1. The plus 2 is going to move it up 2. That's all you're responsible for. The number in front of the parentheses, if it was negative, I'd say it is reflected over the x-axis. This is extra that you're not responsible for. If this number is bigger than 1, we say the graph is stretched vertically. So I'm going to say, I'm going to add this on here, but you're not responsible for this. This graph is going to be skinnier than the last graph. The 3 in front of it, because it's a number that absolute value-wise is bigger than the 1, it's going to make it skinnier. If this was a number between 0 and 1, like a half or a quarter, it's going to make it wider. Now, table of values and sketch a graph. Always, when I make my table, I take the number in the middle of the parentheses and change its sign. Find that number on the x-axis. So I'm looking for -1 on the x-axis, and then I'm looking for numbers to the left and right of -1. So when I found -1 on the x-axis, which is changing the sign of that, the numbers to the right of it are 0 and 1. The numbers to the left of it are -2 and -3. This is a really nice table because the vertex is going to be dabbed right in the center of the table. And my top y's and my bottom y's are going to be the same. So I can tell I've done well if the top y's and bottom y's in my table are the same. Again, I'm going to be lazy to get my y's. I'm going to graph this function, hit my y equals, clear, do 3 times x plus 1 squared plus 2. That's the graph eventually I'm going to come up with. I'm going to hit second in table and try to find, there I see -1 comma 2, 0 comma, -1 comma 2, 0 comma 5, +1 comma 14, and then arrowing up, -2 comma 5, and -3 comma 14. If your top y's and your bottom y's and your second from last aren't the same, then you probably don't have the vertex proper. So now I'm going to graph this, and I don't feel like graphing the 14s. My graph just doesn't need to be that accurate. I'm only going to graph these 3 points. So I'm going to plot the point 0, 5, the point -2, 5, and the point -1 comma 2. I'm going to draw my parabola. Theoretically, it does go through the point 114 and -314, but you really are not going to see it on my graph. I don't need my graph to be that accurate. So I made a table of values and sketched the graph. Domain, easy enough to find the domain. So I should label this vertex at -1, 2 because it's going to be important. The domain for all parabolas, I don't need any algebra. The domain is negative to positive infinity. For the range, I need the y-coordinate of the bottom point. The y-coordinate of the bottom point is 2. So the beginning number in my range is going to be 2. It's on the graph, so it gets a square bracket. The graph goes up to the top of the y-axis, which is at y equal infinity. So I'd say the range is from 2 to infinity. For the increasing and decreasing, the increasing part of the graph, so if I want to do this, so at the point -1 comma 2, my vertex splits the graph between the increasing and decreasing intervals. The graph is decreasing to the left of the vertex. It's increasing to the right of the vertex. For the decreasing part, I must say that's from -infinity on the x-axis to -1 on the x-axis. And for the increasing, it's from -1 to positive infinity. So I just look at the region of where the graph is going down and where the graph is going right, up, and only in terms of x. So it's decreasing to the left of -1, which is the interval from -infinity to -1. It's increasing to the right of the vertex, to the right of -1, which is the interval from -1 to infinity. So I'm going to write it's increasing from -1 to infinity, and usually all round parentheses for increasing and decreasing, because at the vertex it's changing directions. It's not increasing nor is it decreasing. Part E, this again has no maximum because the vertex is a minimum. It doesn't have any other humps, so it doesn't have a local maximum. It does have a local minimum. It has a local minimum at x equal -1, and the minimum y value, or the y value at the minimum, is 2. So I'll say the minimum, local minimum value is y equal to 2. And that's everything that we'd be responsible for that particular problem. So these for me are friendly problems. Again, I'm banking on my calculator quite a bit here to do the grunt work, and then the rest of the work there isn't any algebra. So there's really not algebra per se for these problems if you're stealing the table from your calculator. Okay, so 6 gives me this ugly fraction, which means my y's are going to have some decimals when I do my table, and I'm going to round maybe to 1 decimal. My graph isn't going to be that terribly accurate, but I'm not using graph paper, so when I make my x and y column, I'm just going to round my y's to 1 decimal and be content with that. If you want more decimals, I'm content with this. For this graph to describe what it does, the +3 in the parentheses is going to move it left 3. The -1 is going to move it down 1. That's all you're responsible for. If that 1/3 was a negative, it would reflect over the x-axis. I need to comment to that. This 1/3, because it's less than 1, we're going to say it stretches it, it compresses it vertically. It makes it fatter in some sense. So if that number is bigger than 1, we say it stretches. If it's less than 1, we say it compresses, and then we actually spell compresses properly. So we say it compresses vertically, which just means it makes the graph fatter. Again, you're not responsible for this. I just feel this is going to be a fatter graph. I feel obliged to show that to you. So same sort of deal for my table. I take the number in the middle of the x in the parentheses, and I change its sign. So I take the +3 and make a -3 out of it. I find -3 on the x-axis and find numbers directly to the right of -3, which are -2 and -1, to the left of -3, which are -4 and -5 for my x's. I'm going to get my y's and cheat. So now I'm going to break out my calculator, hit my y equal, clear the stuff that's in there. I'm going to put the 1/3 as 1 divided by 3 in a parentheses. If I don't put that 1/3 in a parentheses, I might not get the right y's. I'm not sure if I will or won't, but I know if I put the 1/3 in a parentheses that my y's will be okay. So I did 1/3 times x plus 3 quantity squared minus 1. This is the graph that I'm supposed to get. So notice that it's wider because the 1/3 makes it wider. It crunches it, makes it fatter is better than compresses it vertically, but most authors would say that. Now second table, again I start looking for these numbers. At -5, I'm going to write 0.33. I'll write 0.3 because I can graph 1 decimal anyways. At -4, instead of 0.66, I'm going to write -0.7. At -3, I'm going to write -1. At -2, I'm going to write -0.7. And at -1, I'm going to write +0.3. So I'm going to plot those points. Again, I don't need to be ridiculously accurate. I want to try to get a graph that looks like that a little bit. And the closer it looks to that, the better. But I don't need to be that accurate. So -1 and 0.3. If this is 0.3, is this going to be barely above the x-axis? And I'm not going to have room to label that, but that's the point, -1.3. -5.3 is at the same level. It's slightly above the x-axis. The next 2 points, the -2, -0.7, is going to be below the x-axis, but not all the way down to -1. So the -2.7 and -4.7 are just about that low, 7/10 of the way between the origin and -1. And the last point I get is -3, -1, and that I can do probably reasonably accurately. So now I've done table of values and sketched a graph. I haven't done the domain and the range. Again, all parabolas have domains of negative to positive infinity. There's no work to do for that. The range for this graph is just like the last 2 ranges. I find the y-coordinate of the bottom point, which is -1. And this graph goes all the way to the top of the y-axis. Eventually it goes to y equals infinity. So the range is going to be from -1 to infinity. And the increasing and decreasing work similarly. If I break this graph up on either side of the vertex, the region to the left of the vertex is where it's decreasing. The region to the right of the vertex is where it's increasing. This interval, I can consider the interval from negative infinity to negative 3. That's to the left of negative 3 on the x-axis. And to the right of negative 3 on the x-axis, from negative 3 to infinity, it's increasing. So for the decreasing, I'm going to say it's decreasing from negative infinity to negative 3. The increasing, negative 3 to infinity. Always the increasing and decreasing on parabolas are going to include an infinity and the x-coordinate of my vertex. So for this one, I'll say it's increasing from negative 3 to infinity, and it's decreasing from negative infinity to negative 3. I still don't have a local maximum, so for part E, I'm going to say none for my local maximum. It does have a local minimum. It has a local minimum at x equal negative 3, and I'll say the minimum y value. I'm changing my words up each time because it's not that crucial how I word this portion. It has a minimum y value at y equal negative 1. Again, essentially no algebra there. I just blew through this whole thing in a couple minutes because the only part where there would be algebra, I used my calculator to do that for me. 8's a little bit trickier. When I go to do number 8, if you need to, you can think of this as 3 times x plus 0 squared plus 6. If you need to have a parentheses, don't need a parentheses in this problem to be able to do it properly. The only thing that's going to be happened here is the graph is going to be shifted up 6 for that plus 6. There's no parentheses, so there's no left and right. And this 3 is going to stretch it vertically. It's not going to flip it over. Again, you're not responsible for this. But if you wrote on a test that it stretches it vertically as opposed to compressing it, that's fine. It makes it skinnier. If a number bigger than 1 is in front of the x squared, it makes it skinnier. So for my table, 0 is going to be the number in the middle of my table, because had I had a parentheses, it'd need a 0 in there. And then I'm going to find numbers on the x-axis to the right and left of 0, which are 1 and 2, negative 1 and negative 2. Steal all the work from my calculator. So y equals 3x squared plus 6. That's the graph that I'm trying to come up with. And my table, second table, I come down and there's the values. At 2 and negative 2, at negative 2 I'm at 18. And at positive 2 I'm at 18. I'm not going to graph those points. I'm not going to squeeze them in there. At both 1 and negative 1 I'm at 9. And at 0 I'm at 6. So again, I can tell my table was a nice table because of the symmetry in the table. The top y's and the bottom y's being the same is a good thing. So now I need to try to fit these points on here best I can. Again, I don't need to be that accurate. So I'm plotting the point 1, 9, negative 1, 9, not fitting the 18s on there in 0, 6. Not labeling the points maybe as nicely as I should, but that's okay. So again, that's my graph. It should be definitely more of a U than a V. There's a reasonable picture. So now I've made a table of values. Now I do the domain and the range. For all parabolas, the domain's going to be negative to positive infinity, so I don't need to do any work with that. The range, I take the y-coordinate of the bottom point, which is 6. The graph goes to the top of the y-axis, which is at infinity. So the range is going to be from 6 to infinity. The increasing and decreasing, I pull off the graph and I segment it on either side of the vertex. So the vertex is at 0, 6. And this is the region where it's decreasing. It's decreasing from the far left edge of the x-axis, which is negative infinity, to the x-coordinate of the vertex, which is 0. It's increasing from the x-coordinate of the vertex was 0 to the far edge of the right axis, which is infinity. So the decreasing is going to be negative infinity to 0. The increasing is going to be 0 to infinity. Need to get a parabola that's flipped over here. Has no maximum value. It has a minimum value. Has a minimum or local minimum at x equals 0, and the minimum y value is y equal to 6. Really need a one that's turned over, so hopefully the next parabola it has a negative in there so we get it reflected over the x-axis and flipped over. Finally, I see it there. Lots of 3's in this problem. When I do part A to describe it, this negative is going to reflect it over the x-axis. So that needs to be shown. It's going to flip it upside down. If he just makes it upside down, that would be completely fine, rather than being formal and saying it reflects us over the x-axis. That minus 3 is going to shift it to the right 3. That minus 3 there is going to shift it down 3. And the fact that this 3 is bigger than 1, it's going to stretch it vertically and make it skinnier. And again, you're not responsible for the stretching or compressing. Okay, so now I'm going to put negative 3. I'm going to change the sign of that negative 3 to positive 3, put that in the middle of my x column. Now find that positive 3 on the x-axis. Take numbers to the right of 3 and to the left of 3, which are 5, 4, 3, 2, and 1. Find my y's. And again, I might not wind up graphing all these points. So hit my y equals, do negative 3 parentheses, x minus 3 squared minus 3. My graph's going to look something like that. It's going to be flipped over. Second table, hunt around till I find the 5. At 5, it's at negative 15. And similarly at 1, it's at negative 15. At 2, it's at negative 6. And at 4, it's at negative 6. And at 3, it's at negative 3. Again, I'm only going to plot 3 points. I'm not going to plot the top and the bottom point because I just don't need that accurate a graph, and I don't have room for it anyways. So I just need to get down to negative 6. And I'm going to plot the point 4, negative 6, 2, negative 6, and 3, negative 3. And try not to draw a V. It's so tempting to draw more of a V than a U. That's a reasonable graph for the so that's part B. For the domain, again, the domain is just going to be negative to positive infinity. There's no newness there. But when it's flipped over, the range is different. The range, I go from the bottom of the y-axis, which is at negative infinity, to the top of the top y, which is at negative 3. So the range is going to be different. Because I always read from bottom to top. The bottom of this graph goes down to negative infinity on the y-axis. So I'm going to say the first number in my range is negative infinity. The last number in my range is going to be the y-coordinate of the top of the graph. Because the vertex is a maximum, it's at the top of the graph. The top of the range is going to be at the negative 3. When I go to do the increasing and decreasing, I look at this graph on either side of the vertex. So I've got this region and that region. This is the region where the graph is increasing, because as I go from left to right, it's increasing. It starts at negative infinity on the x-axis and goes up to 3 on the x-axis. And then at 3 at the x-axis, the graph turns around, and then from 3 at the x-axis all the way to the right edge of the x-axis to infinity, it's decreasing. So I'm going to say it's increasing from the left edge of the x-axis, negative infinity, to 3 on the x-axis, and it's decreasing from 3 on the x-axis to infinity. So let me write that in here. So I'm going to write increasing from negative infinity to positive 3, and it's decreasing from 3 to infinity. This graph, unlike the last three, has a maximum but not a minimum. The vertex is a maximum, so we'll say it has a local maximum at x equal to 3, and we'll say the maximum y value is y equal to negative 3. And then for the local minimum, because this graph only has a high spot, it doesn't have a low spot, it doesn't have a local minimum. So there's nothing to do for that part of 10. Imagine you're getting tired of these. Hopefully I don't have too many more of these. Only one more of these. Another one that's flipped over. The negative reflects it over the x-axis. So in my description, I'm going to say it's going to reflect over the x-axis. This plus 1 makes it go left 1. That plus 5 makes it go up 5. That's all you're responsible for. That 2 is going to stretch it and make it skinnier. We say it vertically stretches it. Take the sign of the plus 1, change it, put a minus 1 in the middle of my x column. Now I'm going to find that minus 1 on my x-axis. Take numbers to the right of minus 1, which are 0 and 1, to the left of minus 1, which are minus 2 and minus 3. Those are my x's. Steal the y's from my calculator by going y equals clear negative 2 times x plus 1 squared plus 5. That's the graph that I'm trying to reproduce. Second table, try to find the negative 3. At negative 3, I'm at negative 3. That's not so bad. And at 1, I'm also at negative 3. At 0, I'm at 3. And at negative 2, I'm at 3. And at negative 1, I'm at 5. Plot those points, connect them, I'll be done with part B. So I'm plotting the points. So I need to go down up to 5. 1, 2, 3, 4, 5. And down to 1, 2, 3, negative 3. So plotting the point 1, negative 3, negative 3, negative 3, 0, 3, negative 2, 3, and lastly, negative 1, comma 5. Again, it's not the ultimate best graph, but it doesn't have to be the ultimate best graph. I didn't even go through that point. The only point I really need to see is the vertex, because that's going to help me answer the rest of the questions. So there's part B. No work on the domain. The domain for all these parabolas is negative to positive infinity. No algebra to do for that. Don't even need to look at the graph. For the range, I go bottom to top. This graph goes all the way to the bottom of the y-axis, so the beginning of my range is going to be negative infinity. The end of my range is going to be the y-coordinate at the top of the graph, which is 5. So the range is going to be negative infinity to 5. For the increasing and decreasing part, I break the graph up at the vertex. Go to the left of the vertex, to the right of the vertex. This region, the graph is increasing, and this is the region from the far left edge of the x-axis at negative infinity to the x-coordinate, the vertex of negative 1. I'm going to say the graph is increasing there. And then this is the region where the graph is decreasing from the x-coordinate of the vertex to the end of the x-axis, which is at positive infinity. So I'm going to say it's increasing from negative infinity to negative 1. It's decreasing from negative 1 to infinity. So increasing negative infinity to negative 1, decreasing negative 1 to infinity. It does have a maximum value. It has a local maximum at x equal negative 1, and we'll say the maximum y value is y equal to 5. So you should hopefully now be able to do all of the first style of problem where it asks me to do these A through F instructions. The next bank of problems have a much smaller instructions. It says, use completing the square to rewrite the problem in standard form. Sketch a graph, make sure to label your vertex. So I'm going to try to write these problems so that they have a parentheses. And it's a little bit tricky. So what I'm going to do first is I'm going to group the x's. So I'm going to try to make these problems look like the first problems. First step is group the x's. I throw them in a parentheses. Now I'm going to find a c. We've done c's by completing the square. C is going to be half of that 10 squared. So half of 10 squared is 5 squared, which is 25. So I'm going to find c. I'm going to add it inside the parentheses and subtract it outside the parentheses. So now I'm going to add and subtract my c, which almost feels illegal, that I shouldn't be allowed to do this. But what I'm going to simultaneously do is add and subtract 25. That's legal because adding and subtracting 25 is just adding 0, which if I simplified this and got rid of the parentheses, it's simplified to my original problem, and that's okay. Now I'm going to factor these and combine these. When I factor, fortunately there aren't any minus signs, so when I go to factor that x squared plus 10x plus 25, first are a couple of x's because there's not a number in front of the x squared. My lasts have to multiply to 25 and add to 10, and they're going to be 5 and 5. The minus 11 minus 25 combines to be a minus 36. So this gives me, if I write this nicer, x plus 5 quantity squared minus 36. So now I'm done with part A. This is using completing the square to write the problem in standard form. Now I'm going to graph this, and I'm going to have to be clever with my window. In terms of being clever with my window, I need to look at the function and decide what a reasonable window is. I know if I change the sign of the number in the parentheses, that's the number in the middle of my table, that's going to be the x-coordinate of the vertex. That number is going to be the y-coordinate of my vertex. When I go to do part B and I steal a graph from my calculator and I label the vertex of this parabola, because it's written in such a nice form, I change that sign and get the x-coordinate. I keep that number and get the y-coordinate. So when I go to graph this function, my window needs to show the vertex. Well, the x's at negative 10 to 10, that will show the x part of the vertex is at negative 5. But if I left the y min and y max at negative 10 to 10, I wouldn't see the y-coordinate of the vertex of negative 36. So I'm going to make my y min cover up that negative 36. And I don't like my vertex to be so close to the bottom, so I'm doing negative 50 as opposed to negative 36 or negative 40. And I don't mind if I don't have symmetry. I'm going to leave the y max at 10. I could graph either function. A real safe thing to do is graph both. If I enter this one as y1 and that one as y2, if I've messed up, I'll see two different graphs. If I haven't messed up, my graphs will line right up on top of each other. So I'm going to hit y equals, let me do x squared plus 10x minus 11, and then also x plus 5 squared minus 36. Hit my window button. Negative 10 to 10 on the x's I said was okay, but I wanted to make my y min negative 50. Now I cross my fingers. If when I hit graph I see two different graphs, then I've messed up, because these graphs are supposed to, the equations are supposed to have the same graph. So it graphs the first one just nicely. Now it's drawing the second one. The fact that I can't see it drawing the second one is because it's drawing it right over the first one. My answer is perfect. And to show you that this vertex is -5, -36, I can do a real quick thing on my calculator. Hit the second button, hit the trace key, hit enter on value, type -5, and hit enter, and it shows me the vertex is at -5, -36. Again, I did second, trace, enter on value, I typed -5, and it showed me the vertex was -5, -36. I didn't have to do the other calculations that we did before because I knew what the vertex is. And for me, this is a more than awesome graph. Here's the point, -5, -36, and I'm just going to kind of steal it a little bit. The graph looks like it goes something like that, and make it so it's symmetric. And that's all the accuracy. So I said you can sketch a graph, make sure to label your vertex. You may use your calculator instead of making a table, meaning I don't care how accurate your graph is here as long as it looks kind of like the function and has the vertex labeled. I know that we could steal a table of values and plot the points and make a more accurate graph, but I just didn't want to get into that. I figured we did enough graphing with the last 12 problems that I didn't want to overkill the graphing. So that's everything to do for part A. I'll do the same thing for part B. I'm going to rewrite the problem so that I can pick out the vertex by looking at it. So I'm going to group the x's. I'm going to write m of x equals to x squared minus 2x. Leave some room. Plus 6. Find a value for c. C is half the number in front of the x to the first power term squared. So that's going to be half of -2 squared, where there's the -2. Half of -2 is -1. -1 squared is -1 times 1, which is +1. So I'm going to go m of x equals to x squared minus 2x plus 1 inside the parentheses. And then outside the parentheses, I'm going to minus the 1 to keep the balance. I'm adding and subtracting 1. If I simplify this by dropping the parentheses and combining like terms, it would simplify to the original problem. Factor and combine. This first parentheses that I have, the firsts are a couple of x's. When I go to factor this x squared minus 2x plus 1, my signs are minus and minus. My last multiply to 1, add to 2, that's 1 and 1. So this factors into x minus 1 times x minus 1. Those numbers, 6 minus 1 is a plus 5. So I can rewrite this problem as x minus 1 quantity squared plus 5. So the answer to part A, using completing square to rewrite the problem in standard form, is m of x equals to x minus 1 squared plus 5. Now I'm going to steal the graph from my calculator, and I want to know where the vertex is. The vertex is going to be found by changing the sign of the number inside the parentheses. -1 goes to +1, keeping the sign of the number after the square. That's the y-coordinate of the vertex. The vertex is going to be at 1, 5. So when I go to graph this, the vertex being at 1, 5, I'm going to put back to my standard window. I'm going to go x min -10, x max 10, because my vertex is at 1 for the x. -10 to 10 will show the vertex. Similarly, I'm going to go y min and y max back to -10 to 10, because that covers up the 5. And I'm going to graph both functions. I'm going to graph y1 as x squared minus 2x plus 6, and y2 as x minus 1 squared plus 5. Again, if I see two distinct graphs, then I've messed up, that my new equation doesn't equal my old equation. So I hit my y equals button, clear, clear, type in x squared minus 2x plus 6 and x minus 1 quantity squared plus 5, enter, fix my window, -10 to 10 and -10 to 10, hit my graph button, graphs the first function. If it stops and I don't see two graphs, then the two graphs were right on top of each other and I did perfect. Again, I'm going to steal this graph. When I copy, I said we just don't need that accurate of a graph. What I need to show is the vertex. I'm calling that the 0.15. Notice I'm not barely labeling anything, and I'm going to draw something that looks, more or less like my calculator gave me. And that's more than accurate enough without plotting any points other than the vertex and copying that. That is well more than accurate enough. They kind of have the same vibe, the same feel. If I wanted a more accurate graph, I'd force you to plot points, but I'm worried about the part A, and being able to pick out the vertex are what I'm really testing on here. Those were the friendly problems. They get a little bit harder, but not crazy, crazy hard. The little bit harder is the next few problems that have numbers in front of the x squared. For these problems to do the part A, to come up with the equation with the parentheses, I need to group the x's still. So I'm going to go 4x squared plus 24x minus 6. The unfortunate part about this is if there's a number in front of the x squared, you need to factor it out of its parentheses, because the C method doesn't work when there's a number in front of the x squared. So I did something on this number 18 that I didn't have to do for the last two problems. Specifically, when I grouped the x's, there was a number in front of the x squared. I factored it out. Now I'm going to find my C. C is going to be half of 6 squared. Half of 6 is 3. 3 squared is 9. So I'm going to go h of x equals 4 times x squared plus 6x plus 9 minus 6. I'm not going to put a minus 9 next to the 6 because I really didn't add 9. This 4 would distribute to the 9, and 4 times 9 is 36. Because I, in hiding, added 36, I'm going to subtract 36. So when you factor out a number, the number that I add, I don't add and subtract like I did for the first two problems, because this 4 gets multiplied by that 9. In hiding, if I FOILed this out, I'd get 4x squared plus 24x plus 36. So in hiding, I've really added a 36, so I need to subtract a 36. Now I'm ready to factor. That 4 I'm just going to leave out there. It's not going to impact the factoring. X squared plus 6x plus 9, when I go to factor it, signs are a couple of pluses. My last need to multiply to 9 and add to 6. And 3 times 3 is 9, and 3 plus 3 is 6. The 6 and the 36 have the same signs. They're going to subtract to be a 52. So I'm going to rewrite this for my answer for part A. It's going to be h of x is 4 times x plus 3 squared minus 52. When I go to graph this on my calculator, I need to know the vertex because I want the vertex to be displayed. The x coordinate of the vertex, I take the number inside the parentheses and change its sign. The y coordinate, I keep that. The 4 makes it skinnier but doesn't impact the vertex. So when I go to graph this, the vertex is going to be way down at -3, -52. When I go to get my window set up, my x-min and my x-max can still stay at -10 to 10 because -3 is in that range. But my y-min and y-max can't stay at -10 to 10. The y-max at 10 is not such a big deal, but the y-min needs to cover up that -52. I'm going to make my y-min go down to -60. And that will gobble up the -52. I'm going to graph both functions again. I'm going to hit my y equals, clear out the junk that's in there, type 4x squared plus 24x minus 6 for my y1, and then 4 parentheses x plus 3 squared minus 52 for my y2. And I have them in y2 and y3. That doesn't matter. Tweak my window. I said my x's are going to be okay. I'm changing my y-min to -60. Now when I hit graph, if I see two distinct graphs, I've made a mistake. And I did make a mistake. Oh, so this is beautiful. This showed me what happened, that I made a mistake. Somehow, between here and there, I have a mistake. And let's see if, first of all, if my mistake is a kind one, and it's just in my write-up, and it's not just in my, I typed the functions in okay. So, how do I find my mistake? Two ways. One way is just to start over. That's probably the safer of the ways. So that's what I'm going to... Oh, I see my mistake. The mistake I made is I didn't use my calculator to combine these. Minus 6 and minus 36 is not minus 52. It's minus 42. So my answer up here should have had a minus 42. So this was actually good that I made a mistake. And see how I was able to test myself. There's a beautiful thing about this. Graphing both functions. If you see two different functions, you've made a mistake. And so I knew I needed to look for my mistake. I quickly looked for it. If I didn't find it quickly, I was just going to redo the problem. But now I can just change the second function from that minus 52 to a minus 42. The window that I have is suitable, so I'm going to leave it. Now when I hit graph, I see the first function. I don't see a second function. That's beautiful. Now my answer is correct. Now I'm going to copy this graph onto my calculator. And again, to show you that the vertex is right, if I went second, calc, hit enter on value, typed -3, it's going to show me that the vertex is -3, -42, and not the -3, -52 like I tried to write. So for a graph, I'm just copying this. This point down here, I'm calling the point -3, -42 without labeling anything. And the graph looks like it kind of goes, looks like it goes like that a little bit. Again, I'm not looking for a beautiful graph. That's more than accurate enough. As long as you have the vertex labeled right and it looks remotely similar to what your calculator has. Okay, 20 has an evil negative hidden in front of the x squared that I need to factor out. But just like the last three problems, I'm going to group the x's to start. To get the equation written so I can see the vertex, I'm going to group the x's. If there's a number in front of the x, I need to factor it out. The negative sign in front of the x, I need to factor out. And when I factor it out, it makes the x squared and the 8x go positive. Doesn't impact the -2. So I group the x's, make the x squared have a 1 in front of it, and now I'm going to find the value of c. c is going to be half of 8 squared, which is 4 squared, which is 16. So I'm going to go g of x equals negative x squared plus 8x plus 16 minus 2. And what I've really done here is subtracted 16, because if I distributed this parentheses, I'd get negative x squared minus 8x minus 16. And I want to do the opposite of what I actually did. So since I actually minus 16, I want to plus 16. And the beautiful thing is, if you make a mistake, you're going to catch it if you graph both functions. So it's not a deal breaker if you kind of mess up. And if you're going to mess up, it's probably right there, doing the wrong thing with the number, putting the wrong number there. But if I distributed this negative through, that's what I'd have. So in essence, I actually subtracted 16, so I want to add 16. Now I'm going to factor the parentheses. I'm going to leave the negative sign out front. The parentheses, nothing but pluses. My last have to multiply to 16 and add to 8, and that's x plus 4 and x plus 4. The minus 2 and the positive 16 add up to 14. So this is going to be negative x plus 4 squared plus 14. So this function rewritten is g of x equals negative x plus 4 squared plus 14. I know that the x coordinate of the vertex, I'm going to change that sign, which is going to be -4. The y coordinate of the vertex is going to be that 14. So when I go to sketch my graph, when I do my x-mins, x-maxes, my x-min at -10 to 10, then x-min, x-max at -10 to positive 10, that's still going to show that -4. But my y-min at -10 to 10 won't show the 14. I need my y-max to be higher than 14. I'm going to bump it up to 20 to safely get the 14 in there. So that's the window that I'm going to pick. -10 to 10 shows the -4 for the x's. -10 to 20 covers up the 14 for the y's. I'm going to enter both functions. So I'm going to enter y equals, clear, negative x squared minus 8x minus 2 and negative parentheses x plus 4 squared plus 14. Change my window, negative 10 to 10 and negative 10 to 20. Hit graph. Hopefully I just see one function. Fortunately I do. Make sure my vertex is right. Go second, calc, value, type in negative 4 and hit enter, and it shows me the vertex at negative 4, 14. Perfect. So I need to plot the point negative 4 comma 14 and then sketch a graph that looks somewhat like what my calculator gave me. So it looks something like that. It's not, again, it's not perfect, but it doesn't need to be perfect. That's a super adequate enough graph for what we're doing here. Again, I wanted you to make a table of values and make a more accurate graph. I told you to do that. All right, one more of these kinds of problems, and then just one more new kind of problem, which isn't that terribly hard. I'm sorry, two more of these kinds of problems. 22 wants me to group the x's. So I go g of x equals to negative 2x squared plus 8x plus 3. Make it so there's a 1 in front of the x squared by factoring out a negative 2. When I factor out a negative 2, it changes the sign on the 8x and divides the x by 2. I get a negative 4x. Make sure you don't change that number. Find the c. c is half of negative 4 squared, which is negative 2 squared, which is positive 4. So I'm going to get g of x equals to negative 2 times x squared minus 4x plus 4. I have the plus 3. If I cleared this parentheses, I'd get minus 2x squared plus 8x, and then minus 2 times positive 4 is minus 8. So in hiding, I have minus 8. Over here, I need the plus 8. So I need to do the opposite of what I did. And I actually, because when you multiply the minus 2 times 4, you get minus 8. The opposite of minusing 8 is plus 8ing. Now I'm going to factor. I'm going to go g of x equals. I'm going to leave the negative 2 alone. It doesn't impact the factoring. The last need to multiply to 4, add to negative 4. They're going to be minus 2 and minus 2. The 3 and 8 add up to 11. So this is going to give me g of x equals to negative 2 times x minus 2 squared plus 11. So this is rewriting the problem in the standard form. So now I can look at it and know what the vertex is. The vertex, I changed the sign of that 2 from negative to positive 2. Keep that sign on the 11. The vertex is 211. I think the window that we just did is going to be fine. The window that we just did is negative 10 to 10 on the x's, negative 10 to 20 on the y's. The negative 10 to 20 on the y's has got to gobble up that 11. I'm going to leave my window the same that I had for the last problem. Graph both of these functions. So I hit my y equals, clear, clear. And then one of them is negative 2x squared plus 8x plus 3. The other is negative 2 times x minus 2 squared plus 11. Window was okay, so I just hit my graph button and hope I don't see two parabolas. If I see two parabolas, I've messed up, and I'll try to find my mess up. I don't see two parabolas, so I'm going to make sure the vertex is right. Doing second calc. Enter on value, typing 2 and hit enter, and I see 211 perfectly. So I'm going to copy that graph onto my goal of graphing. So the graph, I would need to plot the point 211. Again, it doesn't need to be that accurate. I'm calling that the point 211, and the graph looks something like that, I guess. And so that's a reasonable graph for number 22. I'm going to skip 24 and get on to the last kind of problems, and hopefully you could do it. It's the exact same skill as problem 22, so I'm hoping you can do that without my showing you. If not, come visit me and I'll show you how to do it. The last 26, 28, last 4 problems give me parabolas, and I need to come up with the equation for the parabola. These are surprisingly easy. You need to know 2 things to find an equation of a parabola. You need to have a vertex and another point on the parabola. And what I do is I take the vertex and plug it into something I call the standard form. A standard form, every parabola can be written as a function that has some number inside the parentheses, or in front of the parentheses, and then inside the parentheses you have the x-coordinate of the vertex with its sign changed, and the y-coordinate of the vertex goes after the parentheses with its sign intact. So what I'm going to do is take the vertex and plug the x-coordinate of the vertex inside the parentheses, change its sign, leave the y-coordinate after the square, keep its sign. So this parabola, I'm going to go f of x equals to a times x minus 2 squared minus 5. This parabola by itself, if I just look at this, the vertex, I change the sign in the parentheses to get the x-coordinate of the vertex. I keep the sign after the parentheses to get the y-coordinate of the vertex. So this parabola is going to have a vertex at 2, negative 5. So it's just doing the reverse. When I had the equation, I changed the sign to get the x, kept the sign for the y, I did the same thing. I took the vertex, changed the sign, put it in the parentheses for the x, kept the sign, put it outside for the y. Unfortunately, I have no idea if this parabola will go through the point negative 113. To get it to go through the point negative 113, I need to put a value in for a. To get the value for a, I change the extra point that's given, and I take the extra point that's given and plug it into the equation. So for the f of x, I'm going to take the y-coordinate of the extra point that's given. And for the x, I'm going to plug in the x-coordinate of the extra point that's given. So this equation without the a is a parabola that has a vertex at 2, negative 5. I take the extra point that's given, its x-coordinate of negative 1, plug it in for the x, its y-coordinate of 13, replace it with the f of x. If I solve this for a, now I'm going to have an equation that has a vertex of 2, negative 5 that passes through the point negative 113. So I'm going to solve this for a. I'm going to get 13 equals to a times, inside the parentheses, both the numbers are negative. I'm going to add them and keep them negative. So I'll get 13 equals a times negative 3 squared. Negative 3 squared is 9, so I get 13 equals 9a minus 5. Now I'm going to add 5 to both sides. I'm going to get 18 equals 9a. Now I'm going to divide both sides by 9. That gives me 2 equals to a. I claim that this equation, f of x equals 2 times x minus 2 squared minus 5, is this particular parabola. And super easy to check. I'm going to graph this function, and I'm going to do values to make sure both of these points are on the graph. I'm going to do second calc value 2 to make sure I get negative 5. And second calc value negative 1 and make sure I get 13. So I claim this is my answer. Super easy to check, so I'll take the time to check it. Hit my y equals button. I only have one function here. I'm going to go 2 parentheses x minus 2 squared minus 5. Hit my graph. It should look like the parabola that we have here, and it certainly does look that way. Now I'm going to check. I'm going to go second calc value, type in 2, and hit enter, and it shows the vertex is at 2, negative 5. That's a good start. The next thing I need to do is go second calc value, type in the x-coordinate of the other point, which is negative 1. When I hit enter, it says 13. I did perfectly. If it doesn't say 13, my a is wrong. And it says 13, so I'm correct. So there is the answer, and I've checked to make sure it was right. Took 30 seconds to check it. Easy to check. And not that hard to do these problems after you do a few of them. 28, I know that I need a negative in front of my a has to have a negative because of the flip over. So this problem has a vertex of negative 2, 6, and an extra point of 0, negative 6. Let me do this. So my initial equation, I don't know what number goes in front of the parentheses, but I know I changed the sign of the x and put it in the parentheses. and I keep the sign of the y-coordinate of the vertex and put it after the parentheses. Having x plus 2 squared, the x-coordinate of the vertex would be negative 2, and this plus 6 would give me the y of 6. So I change sign and inside the parentheses for the x and keep the sign of the vertex number for the y. Now I just need to solve for the a. To do that, I'm going to change the f of x to the y-coordinate of the point, which is negative 6. I'm going to change the x to the x-coordinate of the extra point, which is 0. So I get negative 6, which is the y-coordinate of the extra point, equals a times 0, which is the x-coordinate of the extra point, plus 2 squared plus 6, and I just solve this. Inside the parentheses, 0 plus 2 is 2. 2 squared is going to be 4, so I'm going to get negative 6 equals 4a plus 6. I'm going to minus 6 from both sides. On the left side, both the numbers are negative. I'm going to add them, keep them negative. That'll give me 4a equal to negative 12. Divide by 4, divide by 4, I get negative 3 equal to a. I claim this parabola has the equation f of x equals to negative 3, which is that, times x plus 2 squared plus 6. I'm going to check it. I'm going to graph it, make sure my graph looks kind of like that, and then do a second calc value on negative 2 and 0 to make sure my y's match up. So I entered this on my parabola. I go y equals negative 3 parentheses x plus 2 quantity squared plus 6. Hit my graph. If it doesn't look anything like my graph, I'm worried, but it looks enough like my graph. Now second calc value, type the x-coordinate of the vertex, which is negative 2. Hit enter. I got 6 like I was supposed to. Now check the extra point. Second calc value, the extra point had an x-coordinate of 0. If when I hit enter it says negative 6, my a is right. If not, I have the wrong a. And it says negative 6, so I did perfect. So that answer is perfect. 30 and 32 are the last two that I need to do. These are kind of wide. I suspect the a's are going to be fractions. When you get wide parabolas, the a's are normally fractions. First thing I do is I look at this vertex, negative 2, negative 4. I take the x-coordinate of the vertex, change its sign, put it inside the parentheses. Y-coordinate of the vertex, keep its sign, put it after the parentheses. So a parabola that has x plus 2 squared minus 4 is going to have a vertex at negative 2, negative 4. Now I'm going to take the extra point. The extra point is x equal 4, y equal to 5. I'm going to change the f of x to 5, which serves as the y. I'm going to change the x to 4. And I get 5 equals a times 4 plus 2 squared minus 4. So I'm going to get 5 equals a times 6 squared minus 4. This gives me 5 equals 36a minus 4. I'm going to add 4 to both sides and get 9 equals to 36a. Divide both sides by 36. I get 9 over 36 equals to a. 9 over 36 reduces to 1/4. So I claim, I think, this parabola has the equation f of x equals 1/4 in front of the parentheses, and then x plus 2 squared to get the minus 2 for the x-coordinate of the vertex, minus 4 to get the minus 4 part of the vertex. Again, I'm going to graph this and check because it takes me 30 seconds to check, and it's easy to do. So hit my y equals button, clear, put the 1/4 in the parentheses. I'm going to go 1 divided by 4 parentheses, and then x plus 2 squared minus 4. Hit my graph. Hopefully it looks something like that graph. Kind of does. It's a little bit wider, but my window is different. That's possibly okay. Now, second calc value, type in negative 2. When I type in negative 2, I better get negative 4, and it does. Second thing I'm going to do, second calc value, I'm going to type in 4. And when I type in 4 and hit enter, I better get 5. If I don't, I made a mistake, but I did, so I haven't made a mistake. So perfectly done, able to check my answer. Just a few steps worth of algebra to get there. Last problem. Same deal here. Come up with an equation that has an a and solve for a. So in this particular problem, the vertex is -2. I'm going to write f of x equals to a. Inside the parentheses, x coordinate of the vertex, change its sign. Outside the parentheses, y coordinate of the vertex, keep its sign. So I get f of x equals a times x plus 2 squared plus 3. That's just with the vertex. The point is x equals 8, y equal -7. I'm going to change the f of x to -7. I'm going to change the x to 8. And I'm going to solve for a. So I'm going to get -7 equals a times 10 squared plus 3. 10 squared is 100, so I get -7 equals 100a plus 3. I'm going to minus 3 from both sides. And when I do that, I get -10 equals 100a. Divide both sides by 100. I get -1/10 because that reduces to -1/10, so I get a equals to -1/10. I claim my answer, the equation for this parabola, is f of x equals -1/10 times x plus 2 squared plus 3. Again, just takes no time to check it, so I'm going to check it. I'm going to graph it, make sure the graph looks something like the equation. Plug in -2 to make sure I get 3. Plug in 8 to make sure I get -7. And so I know I don't have a mistake if I do that. And it takes so little time to do it. So parentheses, -1 divided by 10. Parentheses, -1 divided by 10. Parentheses, x plus 2 squared plus 3. So this is the function I'm supposed to enter. Hit my graph button. Graph should look something like that graph, and it more or less looks something like that graph. Again, I've got a different window, so it looks a little different. And then second calc value, type in -2 and hit enter. I see 3, that's good. Now second calc value, type in 8 and hope I see -7. Second calc value, type in 8 and hope I see -7, which I do. Perfect, my answer is correct, and I'm done. So a lot going on in this section, 3 different styles of problem. Hopefully none of them felt that humbling and you felt real good. So we have 3 styles of problems. The first bank of problems, I gave you a parabola that had a parentheses. We made a table of values by changing the sign of the number in the parentheses, filling out the x column, plotting the points, talking about the increasing, decreasing maximums and minimums. Second bank of problems are the algebra problems where I had to group the x's, find a value for c, add and subtract, factor, and come up with an equation that I could pick off the vertex. And then the last group of problems, we had the pictures that we need to come up with an equation for. So hopefully those went well. Having 3 kinds of problem in one section is sometimes a bit much to ask, so hopefully that didn't feel overwhelming.